Some websites provide APIs for users to directly interact with their data. Rather than scraping content off web pages, with an API you can access the data in ways allowed by its owner. Many popular APIs have wrappers or packages in R, Python, or other languages that simplify the use of specific APIs. In this video, we will use the wrapper tidycensus in R to show how to pull neighborhood data from the US Census API. First, let's install and load the needed packages. If you have installed this before, you no longer need to install it again. Just run this library line to load the packages tidycensus and tidyverse. We'll use SF in a later video, but not in this video. You should have obtained a US Census API key, so you need to use the Census API key to set it to the environment. So replace your API key with the key you got, and if you set install as true, you no longer need to set this API key next time you restart RStudio. But if you just want to use it one time, then you don't need this. So the basic functions in tidycensus for getting information, these get functions. You can get ACS data, you can get this annual census, you can get population estimates or POMS data. We have pretty similar syntax. Let's use the documentation of get ACS as example. See these, there are a lot of arguments, but you don't need to use all of them. Typically, you want to set geography, which is the spatial unit you want to request data for. Variables will be a list of variables, or you can use table to pull all the variables from a certain table. You can set cache table to true for faster access later. Year should be either the year of the census or the last year of 5-year or 3-year ACS. You can also specify the state and county. If you set geometry to true, you will get a simple feature dataset. Remember the SF dataset we worked with before, which will contain the spatial information. For ACS data, you will also get the margin of error, so you can set the confidence level using this MOE level, which by default is 90. You can set it to 95 or 99. Survey default using get ACS, you will get 5-year ACS data, and default year is 2014 to 2018. But you can also set ACS 1 or ACS 3 here for 1-year or 3-year estimates. As example, let's try to get the census tract level population for the DeKalb County, which includes city of Chambly, which we want to work on for this project. It will be helpful if we know the variable names from ACS. So there's a function load variables that can help you with that. Let's say we want all the variable names for a 2014 to 2018 5-year ACS. So use load variables, and here you have to set the year and the data set. The year is 2018, and data set is ACS 5. Now we have all the variable names in this data set. You see you have names, label, and concept. You can either filter using our script, or you can filter and search here. I'm going to search for total population. You can either do this in the label or in concept. The label here can be a little confusing. It has to be combined with the concept to know what exactly each variable is. It seems like this is the total population. Copy the variable name and put it into my get ACS. First set the geography, which I want to do census tract. You can also set it to state, county, blocks, block groups. So variable list. So we'll just copy it. to assign it to a data object called pop18. Alright, I can use, you can either use view or add to check your data set. Right, you see it's read as a table, and there are 5 columns: GeoID, the census tract name, variable is variable names, which is the same as this, and you have 2 columns called estimate and MOE, which is margin of error. So remember, margin of error is by default 90% confidence, but you can set it to 95% if you want. Okay, yeah, different numbers compared to these, right? Don't need it for now. There are some useful functions in tidycensus that can calculate margins of error for you when you calculate a proportion, a product, or sum using ACS variables. Let's say we can calculate percentage of Hispanic population in each census tract in county of DeKalb. So let's search for Hispanic. It's actually the white population. Alright, that should be the total Hispanic population. So now we have more than one variables. I need to use C, remember, it's just the function that connects elements into vector. Make sure you always pair your parentheses and quotation marks. Now you see we have 2 variables here, but we still have only 5 columns. So you can see the variable column contains the variable names of the 2 different variables that we used, and the estimate has the estimate values for both variables, and MOE contains the margins of error for both variables. So you might know that this format of data storage is often referred to as the long format. In contrast, you might see data in white format where each variable has its own column. We often need to convert data between long and white forms, and there are different options for doing this in R. There is the reshape function in base R, the reshape2 package, which comes with the melt and decast functions, and the tidyverse under the package tidyr, they're gather and spread functions. And there's a new pair of functions that's replacing gather and spread called pivot longer and pivot wider. Let's first try to use the gather and spread functions to convert this dataset to the white format so we can calculate proportions from different columns. The basic arguments of the spread function, which converts data from long to white format, data, just dataset we're using, pop18 here, key, which is the column containing the variable names for the white format dataset, and value, which contains all the data values. And you see we have an obstacle here. The key column is obviously a variable, which contains the variable names, but we have 2 value columns, right? Estimate and margin of error. If you don't need margin of error, that's totally fine. You can simply use estimate. But here, because we want to demonstrate how to use the other functions in the tidycensus package to calculate margin of error for proportions, products, and sums, so we do need to preserve the margin of error. And it seems like we need to first use the gather function, which converts dataset from white to long, to first combine these 2 value columns. So let's do that first. And the syntax is pretty similar to that of spread, but here the key is the new column that we're creating, which I'm just going to call it key, which contains the variable names, currently, estimate, and MOE. And the value is also the new column that we're creating to collect the values. But here also you need to set the columns that we're gathering, because otherwise they will just gather all the columns, but we do want to keep some of them separate, like GeoID and census tract name. All we want to combine estimate and MOE, so I'm listing the column names here. Right. We check the data set again. You see estimate and MOE up into the key column, and their values are combined into the value column. So now we have another problem. We have one value column, but we have two key columns, right? The variable column contains the variable names from ACS, and key column contains whether it's an estimate or a margin of error. So let's combine these two columns into one new key column, and we can use the paste function to combine two string columns. We use mutate for that. See, every time I've been just overwriting the pop18 dataset, but you can also choose not to overwrite. You can give it a new name. So, and here I'm gonna overwrite the key column as well. I'm gonna call the new variable key, so that will overwrite the current key column. And paste function will concatenate two or more strings, and here you see a separator argument, sep, which by default is a space. I'm going to use, so these are the strings you want to combine. Here I give it two columns, which means for every row of the two columns I want to combine those strings, so it will be variable names followed by estimate or MOE. And I'm using the underscore as a separator, but you can use anything else. If you want to use another string, you want to put a word in between, that's totally fine. If you don't want to use anything, you can leave it empty like that. But if you don't want to use a separator, you can also use the function paste 0, which will not have the sep argument, and it will not include any separator between strings that you combine, and it will run slightly faster. But here I do want to use underscore. But before we run that, let's first change the variable names, because the ACS variable names seem not very intuitive. We don't necessarily know what B01001 is. Let's change those to something that's more meaningful to us. You can either recode here, right? You can use the mutate function to do that, or you can set it directly when you make the data request using the Census API. You see here in the variables, I only listed the ACS variable names, but I could have give them new names. So call total population pop and Hispanic population. So that will require me to rerun all these previous steps. Which luckily it's not much. And now you see the variable names are replaced to his and pop. Let's use paste to concatenate the variable names and estimate or MOE. So you see the key column now is our new key, and that's all we need. So we no longer need this variable column anymore. So I'm gonna remove that from, I use pipe to link all these operations. First I'm using select to drop the variable column. And then I'm going to use spread. Here the key will be the key column. And the first key is the argument key, right? I'm giving this variable key to the argument key, telling the function that I'm going to use the key column as the column that contains future variable names. And similarly, I'm using the value column as a column that contains all the values. Now after this step, we should have a data set with 4 columns containing estimates and margin of error for the 2 variables. But I'm gonna just go ahead and use mutate to calculate the percentage that we want, and percent that will be Hispanic estimate divided by population estimate. And I'm also gonna calculate its margin of error using this MOE prop. And you see here there are 4 possible functions, all in tidycensus. I'm going to use proportion here. And there are 4 arguments here: the estimate of the numerator, the estimate of denominator, and margin of error for the numerator, and margin of error for the denominator. It's just the 4 columns that we just created. Yeah, we haven't created yet, but it will be created in this step. So the first one is estimate. Denominator. And okay, you can open it here and you see these 4 columns are created by the spread function, right? We separated each estimate and margin of error into its own column, and we also created these 2 new columns with the percentage and the margin of error of the percentage. And after this data set is converted to the white format, we see there are 145 census tracts in DeKalb County. Now, let's see how to use pivot longer and pivot wider instead of gather and spread to achieve what we just have done. So I'm going to go back to the first step. Because I have overwritten this data set, I'm going to make the data request again. And here instead of gather, I'm going to use pivot longer, which also changes data set from the white to long format. And the corresponding arguments, instead of key and value, it's names 2 and values 2. Okay, so that's kind of more intuitive, right? Names 2 is the new column that you want to put your current variable names into, and values 2 is the column that you want to put your current values into. And also has the calls argument, which is the list of the columns or variables that you want to gather. So I'm using C here to combine the 2 columns that we want to combine, estimate and MOE. And you should see here similar results, right? The estimate and MOE columns combined into this key and value column. So we can just repeat this step here. Shouldn't need any changes. And here I want to replace this spread function with pivot wider. And similarly, instead of key and value, the corresponding arguments are called names from and values from. All right, everything looks the same, right? Now that we've learned how to use gather, spread, or pivot longer and pivot wider to convert data between long and wide formats, I need to tell you that this is not exactly necessary in this example. We could have just used the data request, solved that issue here, but don't be mad because we just learned something very useful. Back to this get ACS function, we could have set output to white, which would have created a white format directly. Let's check. So you see here, there are also 145 observations instead of something like 500 in the long format. So that means every census tract has its own row, and every value, or either estimate or margin of error, will have its own column. So there are 4 columns of data, pop E, pop M. So you see the first part of column name is still the variable names that we set here, and E means it's estimate, and M means it's margin of error. Great, so you could directly do this last step, calculation of percentages and margin of error for percentages, instead of doing all these white long conversion. Or alternatively, in this case, you could use, so this is still get ACS documentation, you could have used this summary variable argument, which will get a summary variable, in this case that's total population. So we could have moved to the population here. I'm no longer using the output white argument, but I'm moving total population down here. See? Alright, now similarly 4 columns, but the column names are a little different, right? If we have more than one variable here, they will still be all listed here and in estimate and margin of error columns. But here we can still do the calculation of percentages and margin of error of percentages directly. Right. This method may not work very well if you have a more complex list of variables, like multiple summary variables or something, but in this case, it does work.